was not being spent, right? So that is something that you can try to look at, right? So then the Times of London newspaper said Chancellor is bailing out banks. Bitcoin's libertarian roots is what they said. So in fact, the Chancellor of banks, you have the RBI governor who is the Chancellor of the bank, and they are bailing out. In fact, what is the thought process here is that banks usually charge a transaction fee, and when people wanted to avoid the transaction fee, right? So that's where this thought process came in. Let's have a ledger. I don't know how many of you remember the ledger, because the blockchain concept is put up in a technology called DLT. It's a distributed ledger technology. Now, what is a distributed ledger? To understand the actual technology, a ledger is like a bank account, right? So I think Professor Sandeep Shukla also mentioned this. So when you go to a bank, of course, now you don't go to a bank, you mostly do the banking on internet. So earlier when we used to, when I was a student, I used to go to the bank and make a transaction. People would... Yes, ma'am.
Professor Pilli, some people are saying not visible, Neeraj and one student Mithai. Can you please tell participants, screens are not visible, I'm getting. Can you please unshare, because I can see the...
Okay. I'll reshare, ma'am.
Okay, so somebody, my student told that you have no longer, you're no longer a co-host. Let me just...
I was just trying to share. I'm not able to share now.
No, just a minute. Yeah. I was able to see, but not everybody was able to see. Now I'm making you co-host. Sure, I've already made you co-host now. Can you just see if everything is fine? I'm able to. Fine. So there's a lot of uncertainty in these online things.
Yes.
Now visible. Thank you, Ajit ji. Thank you, everybody. Yeah, thank you, everybody, for telling this. Yeah. We can start.
Sure. Sorry. Of course, the flow was going on. Anyway, let's continue. So the point that is there is why blockchain has come into the picture is to make everything a public ledger, right? That's where the distributed ledger technology, that's what is the technical term for a blockchain, right? So we have a public ledger, which is open. It is like, you'll be surprised to know if you have a bank account and everybody can see all the transactions, right? That's what blockchain is. Oh my God, you will feel very bad, right? So, but the point that we are trying to look at is, 1 minute, sorry. The point that we would like to look at is that anybody can see all your transactions, whom you are sending money, whom you are receiving money from. That would be a public ledger. Then you will not be happy. Why should people see? But if somebody told you, nobody knows who you are, right? Nobody knows whose bank account it is. Nobody knows, but all the bank accounts are open, but nobody knows whose bank account it is. Then you have no problem, right? Okay, go ahead, right? So basically, as we look at it, blockchain is something like this. All the transactions that you're making is public and everybody can see. Maybe people can also guess how much money you have or how much money is there over a period of time. That's what I'm trying to look at. Now, why am I trying to give this introduction? I'm trying to give this introduction because if we don't understand these things, then we will not be able to really understand security aspect. So let me take you through this. So this is what the basic idea why Bitcoin was created. Two things. One thing is we don't want to pay any transaction to the bank. That was the point. Second point was we don't want any of the transactions to be identified. Now, one of the great things that the present government has done for us is all electronic transactions. They have encouraged a lot, right? I've got Paytm, Google Pay, and UPI, and so many things. And all banks transactions are there. And then when, of course, I don't know how many of you are paying tax. Students may not be paying tax, but faculty, most of you may be paying tax. Then you have to declare your bank account number. So at the end of the day, all the transactions that you do are logged. So you cannot, I mean, you are accountable for all of them. So anybody who doesn't want to be accountable wants to look at some of these things. But so these are 2 points. First point is I don't want to pay any transaction fee. Second point is I don't want anybody to know my transactions. a kind of you can say hawala, if you have heard that word, or black money otherwise. But then there is a lot of reputation also that is involved with the blockchain. It is not that negative because it can be used as a stock also. I was discussing these some of these thoughts with my students, and they are more aware. They are doing transactions, and they are doing how the sales of the Bitcoin is going on. I will share some of those thoughts as well. So the first point is now not more valid because earlier transaction fee was not there. You can send money, you can receive money, no problem. Money in the sense cryptocurrency or bitcoins. You can send bitcoins, you can receive bitcoins, no problem. No transaction fee. But now, as we realized that more and more bitcoins are generated, only few bitcoins are to be identified. So once after all the bitcoins are identified, there's not going to be any more rewards, because the halving, as somebody would have explained to you, I will also show you the table. But then after some time, there'll be no rewards. When there is no reward, what will be the motivation for miners? What will be the motivation for blocks to be added? It will be the transaction fee. And some of those concepts become very important, because if the transaction fee is more, I will include those transactions into my block. Now there will be miners who will become very selfish as well. So these are some thoughts which will attack. But beautiful concepts that you have learned till now is amazing thought. Who is behind this blockchain? Nobody knows, or Ethereum, or there may be some companies which are doing this permissioned blockchains, but the public blockchains which have been created, wonderful computer science going behind that, wonderful algorithms, wonderful crypto that's going behind that. And I think one of the reasons why Indian government has not yet called blockchain or Bitcoin or Ethereum a legal tender. They have not called it illegal as well, so don't worry about it. You can still buy and sell digital coins, crypto coins, no problem. Cryptocurrency, you can deal with cryptocurrency. You can consider it as a what you call as a stock, I would call it, because the rates are increasing. I will just share with you some of those thoughts. So the interest is huge because the money is heavily involved. So now maybe from an Indian perspective, we are more interested in the commercial value of the Bitcoins as we look at it. But then we should also look at these things. Some of these points is basically Bitcoin is solving an encryption formula. I will shortly share with it, but then it requires huge amounts of power. So that's the catch here. You get a lot of money because when you solve a Bitcoin problem, you get some Bitcoins as a reward, and those Bitcoins are huge in cost. So that money you can convert it into US dollars, Indian rupees, or any of those things, and then you can use it for something else. So maybe if you look at it, about 6 Bitcoins are given, more than 6 Bitcoins are given today. If you add a block, 6 Bitcoins is roughly now, earlier, maybe in November, it was like 60 lakh rupees. So 6 Bitcoins is like 3.5 crore, I think. So that's huge amount of money, right? Now today, I think it's about 40 lakhs. I will tell you what is the current price shortly in the slides that are coming, right? So and then Bitcoins can be split up into multiple ratios of that, right? But if you want to buy a Bitcoin, or if you want to get a Bitcoin, how do you get it? You can go to a Bitcoin exchange, like a stock exchange. If you want to buy stocks, you go to you have a Demat account and go and buy it. Otherwise, if you want to buy a Bitcoin, you create an account. Maybe one of the popular exchanges called Binance. I will show some slides on Binance. So in the next talk after the break. So there you have some of these Bitcoin exchanges. You can go and pay Indian rupees or dollars or whatever using a credit card, debit card, whatever, and you can buy some crypto coins, right? Bitcoins. You can buy from anywhere. Right? You can have an exchange. It's like your Paytm wallet or Google Pay wallet. Of course, there you deal with only rupees. But Binance or some of these exchanges, they deal with a variety of Bitcoins, and you can sell and buy and all that, right? If you have a friend, he can transfer it to you. If he has some Bitcoins or any of those other coins that are there, you can transfer it. Or you can become a miner. You can mine a block, right? The mining of a block, of course, the only requirement, as I told you, it requires huge amounts of power. And that is, huge hash rate that is required. The Bitcoin current hash rate is 114 million terahashes per second. So that's huge requirement that you need. So these are 3 options how you can go ahead, right? So presently, the terahashes, the hash rate has come down because China has banned the mining, right? Because huge power is getting consumed, and then the country's resources are getting depleted, right? As of now, I don't know whether there are so many miners in India, but then yes, there may be few companies who may be involved, and then they are paying huge electricity bills, but they are doing this this network, right? So this is what I was talking about, halving of Bitcoin. So earlier it was 50 Bitcoins. 4 years later, in 2012, it became 25 Bitcoins. Then another 4 years later, it became 12.5 Bitcoins. Last May, during the pandemic time, it became 6.25. Maybe another 4 years, 2024, sometime early 2024, February, March, it will become 3.125 Bitcoins, because number of Bitcoins are getting reduced, right? So if you look at a statement, you can go to any of those explorers, right? There are the entire blockchain can be viewed. As I told you, it's a public ledger. Anybody can view that ledger. So these are some websites where you can go and look at those ledgers, and you will see the latest block that is getting added, a number of transactions that are getting included in that, who is creating that block. The names of the blocks, usually in pools, they are coming, because earlier it was a single miner who was doing the job. Now single miner's resource is not sufficient, so I have to combine multiple resources and then add it. Of course, size of the block, because all the transactions and everything, and then the time at which it was included, of course, the reward and the transactions that are there. So the transaction amount and everything is added, and the time at which the block is added is there. So yesterday evening, I took out this slide. So the latest Bitcoin, presently it is 717,475. This was like in 2020, August 31, right? August 31st, there were 646,148 was the number of blocks that are added. I'm talking about the Bitcoin blockchain. The standard blockchain, or the traditional blockchain that we would call it, the first blockchain that would call the Bitcoin. Now it is 717,475 yesterday night, right? Of course, I also wanted to take it just now, but then you can also understand that it takes certain minutes for a coin to be added. Usually it is 10 minutes is what is tried to be created, right? 1 minute. Just give me a second. Sorry. Yeah. So yesterday evening is what I was talking about. These are the blocks that are being added, and this is what is going on, right? So roughly, it should be added in 10 minutes. So there is a difficulty level of a block to be added. That is surprising and excellent, right? So just imagine if some blocks are created fast, like in 5 minutes time. As you see, this is 1 minute gap. Some blocks are created in 1 minute blocks. Some blocks are created. So obviously there will be some gap in between, right? After some time, it takes like usually it should take 10 minutes, but then the competition is so fierce that people are trying to create more blocks. But then the Bitcoin blockchain adjusts itself over a period of time. So in a day, only a certain number of blocks get created, right? So usually the time is 10 minutes. So how is that controlled? Somebody else is controlling. I don't know. It has been programmed into it, right? So the difficulty level changes and automatically it adjusted so that some blocks are created fast and some blocks are created slow. Maybe in the previous slide, let's see if that is there. As you see the time here, 47, 36, this is 11, then this is 12, and this is 11. So usually, and then as you see here, after 8, it was like, sorry, not that, 43 and 49 is 6, and this is also 6. So like that, usually, and there is a gap here. If you see 7 and 28, there is a 21 minutes gap here. So difficulty level is increased. So these are some things that we try to understand. But what is actually needs to be done in this diagram, I will show you. This is one block. What is needed is what we need to calculate the next block hash address. We don't know anyway. This is not a concern. But the previous block hash address we know. This is what is found out by the miner. So the previous block hash is already there. So you take Merkle root. Of course, this was explained by Professor Sandeep Shukla. So transactions are arranged. All the transactions that are coming, they are arranged, and then you create a Merkle tree, and the root of the Merkle tree and the hash of the root is called the Merkle root, right? So you have a tree, you have a hash which is created, and the root hash is said to be the Merkle root, right? So you have the Merkle root, and then you have what is called what has to be mined. If the mining algorithm involves, you have to find out the nonce. So now, when all the attacks that I am going to talk now are going to play on this aspect of mining, right? So because this is what I want to play with, this is what I want to do it fast, this is what I want to mess with, is what you can try to understand. The other aspect is a block gets finalized when it receives a certain number of confirmations. Let us say at least 7 confirmations it has to receive. Then the block is added in the next block. So if 2 blocks are added of the same type and 1 block receives more confirmations, this block gets dropped, and then this chain continues. So it's very tricky in that sense. So there are so many jugaads that come into the picture, right? Our Indian mind talks about that, and then people try to see how best I can do it, how fast I can do it. Can I create more blocks faster? That's one thought. How can I use more better hardware? Yesterday, somebody was asking, if I use a powerful computer, yes, we are coming to that also, and we will look at those kind of attacks. So please try to understand what is needed for a block to be added: the previous block hash, the Merkle root, and the nonce value. The nonce value is to be guessed. The nonce value is to be guessed so that the present block hash you can get. So this has to be calculated. What is the input? Merkle root, previous block hash, and the nonce. These 3 values are to be considered, and then you have to calculate the new block. Once you get the new block hash, it's same here, and this value is the same. So you have to create this block, and this block will have sometimes 18, 19, 20 preceding zeros depending on the difficulty of the block mining. So this has to be created. Now, if this is created, the block can be added. Once the block is added by a miner, the first miner who does it, he says, I'm correct, I have solved the puzzle, and I'm adding it. So then their other miners also reach that point, but by that time the block has already been added, and they don't fight with him, or they don't argue with him. There is no mechanism to argue. I was first, or you were first, or whatever, right? There is no argument. If somebody has already announced that block and it is displayed across, and immediately the others will see it, and then before they go to the next block to be mined, they'll say yes. Like that, if 7 or 8 people say yes, then the block is said to be confirmed. The block is said to be added. So there are some multiple blockchains keep running, but then only one continues ahead, because as it receives more and more confirmations, the other blocks get dropped, and then as you take it further. So based on this concept, also there are some attacks, right? So if you can get some of your friends who are miners to say that your block is the right one and give more ticks, more confirmations at the earliest, then you may have an edge. So these are some concepts that are happening, and just imagine the thought at which people are moving. At one point of time, when I tried to look at, because my interest is security and forensics, to every aspect. So for cloud, I started with first I started with network security, network forensics, cloud security, cloud forensics, big data security, big data forensics, IoT, trust management, security, now IoT forensics, and then moving on to blockchain security, and then maybe blockchain forensics. Already one paper has come on blockchain forensics. People are thinking how to do forensic analysis on blockchain. Just imagine the kind of problems that are there, the kind of people, how much people are thinking. a couple of years ago, when I made a presentation on blockchain security, people laughed, and I mean, they were more intelligent people than me, and very well versed in the sense. But they said, what you're thinking is not going to really happen. But unfortunately, or fortunately for me, a couple of years later, that has been a reality. And as we see, blockchain security is very much in place. And then you see a lot of literature, a lot of papers coming up, and then you can also attempt. And some of these things are possible to be shown. So by this background, let me take you forward, because these you have already, people have shown you, you have also listened, but I just wanted to clarify, because whatever I'm going to place before you is based on these thoughts. So as we look at it, these are the transactions that are happening. So you have some addresses which are coming, and some amount of bitcoins that are there, and you are pooling all of these. So mostly when some of these things are coming like this, you tend to realize that they are all mostly may belong to the same address, right? So usually the public address is what is displayed, and whenever it's like your email address, and you can tell it to some people, and then you can create a QR code of it and share that QR code to others, and then they will scan it, and then they can use that public address, because nobody will be able to remember this 35-bit public address, right? And then you have your own private address, or the private key that you call it, and then you can open it. So people, by looking at your public address, they will send you the thing, and then by your private key, you can verify it, claim it, and you can use it somewhere else. So that's something that is understood, right? So these are some things like earlier 10,000 bitcoins were used to buy a pizza. Maybe now you will get 10,000 pizzas, more than 10,000 pizzas for a not even a single bitcoin, even a milli bitcoin will get you that, right? So that's the kind of ratio. It was like a stock. Earlier it was very low, almost like a zero. People say that 50 bitcoins Satoshi Nakamoto did not sell, because at that time it was practically zero. You have to gift out bitcoins free. So he said, let's keep it, right? So those are still there, and they are still unused, right? So they have never been used in any transactions, right? So the other use of this blockchain, the cryptocurrencies, is basically on, as we look at it, on the negative aspects. Maybe you want to buy some drugs. There was something called a Silk Road, right? Silk Road was a popular road in history a couple of years ago, where East and West were connected, and then that was a route through which all of these things were sent. The precious Eastern countries' resources, spices or silk or something, they were sent to the Western countries, right? And then huge resources from there, in terms of money or gold or whatever, was sent back to the Eastern countries. So the Silk Route was a very much, but then there's an online Silk Road which was created, where you could buy some of these things like pornography, or maybe fireworks, or guns and ammunition, all the stuff that an underground world would the world dawn world would need, right? So this was what was the thing. So maybe if you look at it, 2013 the FBI shut down the Silk Road, and in fact if you read some of the important attacks that are happening on blockchain, and how FBI and some of these government investigative agencies are closing, you will be very excited to hear that, right? And maybe you can watch some of these movies also, where these concepts are shown, and how the government acts, and how these problems are solved, right? So why are security attacks happening on bitcoins or blockchains or some of these things? Is because the money is increasing, right? 2017 it was 13 lakhs, and August 2021 it is something like that. December it was 19 lakhs, right? December 2017, right? 19 lakhs. Few years, in the last few years, you see there was a huge interest, and suddenly the Bitcoin rate increased, but again it came down and went on. And slowly, as you look at it now in 2021, this is where it's available on CoinDesk. You can go to this website and you can look at that. There was a point when it became 63 lakhs. This was sometime in 14th April 2021, right? So this was 63 lakhs. And now, recently, in 10th November, the peak, it crossed somewhere around 67 lakhs, right? 66 lakh 935. So that's the kind of 93,589 rupees. That was one Bitcoin, 66 lakhs. Of course, now it has again come down. and roughly it is this thing. So you can see the huge amount that is involved. Maybe something like 70 lakhs someday. One Bitcoin is 70 lakhs, and if you mine a block, you're going to get 4.2 crore of rupees. So that's huge amount, right? And that's where the interest is. Now, if somebody can actually cause a havoc or cause a faster way of earning things, so why not? So that's where the attacks will come in, right? So the PayPal and Tesla, BlackRock, JP Morgan, most of these are using. PayPal is going to allow, it's going to be a legal tender. Bitcoin is going to be a legal tender. You can buy and sell using Bitcoins. And there are so many exchanges, very easy to make these transactions. Only thing is you need to do your KYC. That's what. So some of the recently government also is very keen on understanding, or it wants to control the blockchain, because if people convert the money into blockchain, and when the blockchain cryptocurrency cannot be tracked, they cannot find out what's going on. So they are going to loop in all the exchanges, and they're going to rein them. So all the exchanges have a very strong requirement of KYC. So who is making all the transactions can be easily known by the government. But then if you don't want to go to an exchange, you can directly do your own transactions, and you can manage it, and nobody will know about it, right? So that is something. So exchanges we go because it's easy for us, and we rely on the exchange. So suddenly if someday the exchange closes and he says, sorry, we got lost and we lost your money, it is something like what some of the nationalized banks have done in the past, where they have closed, the privatized banks have closed, and they said, we can't give the investors the money. Now, a lot of banks, you may remember, a lot of investors lost their money. Hard-earned money was placed in the banks as FDs and this thing, and they're lost. So something like that. So there is no centralized agency. Now, if you 1,000 rupee note, if you hold today, it is very risky because it is demonetized, and hence it is not a legal tender. In that sense, it is an illegal tender. But you can have a 2,000 rupee note and a 500 rupee note. It's a legal tender. So as of now, Bitcoin is not legal and Bitcoin is not illegal. But the moment government may declare, for those who don't have, who don't disclose that they are dealing with Bitcoins, they will have to pay a severe one. So there is a slight uncertainty in Indian context. And of course, there are a variety of Bitcoins that have been created. And these are some of the rates, and the rates are varying, but the market cap is more. So Bitcoin is, of course, this is a couple of days old, right? So you can go to that the blockchain blockexplorer.com, and then you can see the latest rates, what's happening, and then you can open a wallet in Binance. I will share that later. So, or you can open on Block Explorer also. You can open a wallet, and all the blockchains rates are readily available there. And then you can just make transactions in between. In the next class, I will deal with, right? So why I already discussed this, right? It is purely a cryptocurrency. You don't have to carry it. First advantage. It is not controlled by a central entity. It's a disadvantage and it's an advantage. Those who want to deal with money which doesn't want to be accounted, right? It's an advantage that nobody is going to observe. But if somebody loses money, then nobody, if your note, 2,000 rupee note gets torn, right, into some part of it, and then you can go to the RBI outlet, or most of the banks take it. And if the banks say it's very bad, we don't want to take it, you go to the RBI. They look at the note, and then they give that, they take that note and give you a new note. There's a central agency which is taking care of you. But in case of Bitcoin, that option is not there, and then you may have to this thing. So you are not controlled by any central entity. It also solves the double spending issue. I think yesterday we had discussed, Professor Sandeep Shukla had discussed on, but that is one of the attacks that I will start with, right, to understand, right? So this is what happens. The basic why blockchain is used otherwise, apart from cryptocurrency, the advantage is it is because it is immutable, right? And there is immutable means any thing that you record on it cannot be changed. it is like your DigiLocker kind of thing, right? Maybe you have most of your public documents which are there, and they can be verified, right? So when a police person asks you for a license, you can show it on your DigiLocker. When you want a 10th class mark sheet or something, you can show it on DigiLocker if you have uploaded it, and people will accept it as valid, right? So because you can't change anything which are there already in that, right? So these are some things which people are so entire copy of the history of transactions is available. So these create a requirement for privacy, right? Just imagine entire data, all the blocks. Now 7,17,000 odd blocks are created. All the blocks, all the transactions in the blocks are available as a big database. Now in this data, now as you know, a lot of machine learning algorithms and data science algorithms, a lot of statistical techniques you can apply on them, and you can find out some relationship. You may not know who the individual is. Now just imagine privacy is something like this, right? Privacy is something like this, that security or confidentiality, if you look at it, it is something like this, that two government heads are speaking. Maybe let us say what is called Biden and Narendra Modi ji are both talking to each other, right? Mr. Biden is calling Narendra Modi ji, and somebody gets the telephonic conversation or an email which is sent by Indian government to US government. Somebody gets a copy of that email, right? And then that's a big issue. That is a security issue. That's a confidentiality issue. Somebody has gone into that. But just imagine somebody knows that Modi ji had called Mr. Biden. That is also news. That also should not be known, because people can guess, what did he talk, what was happening, what are the major national events or international events that are going on, what were the issues with the neighbors, and suddenly when Modi ji had made a call, what does it mean, right? So that is a privacy issue. So in that case, when this whole ledger is publicly available to you, right? And then how are these ledgers, all the transactions coming? They're coming from somewhere, right? In fact, this whole ledger is maintained somewhere, and all the miners and all the people who are doing transactions are connected to the blockchain somewhere. Now, how do you create a blockchain? Maybe you have discussed with Hyperledger, you have set up Ethereum. Some of those examples were discussed for you. So when we set up here the Bitcoin core, we downloaded the Bitcoin, the blockchain software, and then we installed one node, and then you connect it. So obviously, what happens? There is a network connection between blockchain and your node, right? So there is a kind of some information which can get served. Of course, we don't know. If you are intelligent only, then we will be able to understand. So these are some informations that are there. The entire transaction data is there. All the nodes that are connecting, their information will be there somewhere. And then all the transactions data is timestamped. And the basic use is that you cannot change it. So these are some aspects that we look at, and I'm skipping some part of it because you already discussed all of these. These are I will suggest you to visit this andersbrownworth.com/blockchain. It's a simple emulation program, right? To understand a simple how blockchain works, right? And how what is meant by Coinbase. Some of the words are basically introduced. So I'm just skipping that part. So now you try to understand the hash of the transaction is mentioned here, right? And the address is mentioned, which is the public that belongs to you. Whenever you download a node and set up your network connection, you are given a public address and a private key and a public address. So the private key, you keep it with you. That is used to verify the transactions, but the public key is there where you need to disclose this. If you want your friend to transfer money to you or transfer Bitcoins to you, you need to tell him your public address. This public address can be represented as a QR code. You can send that QR code to your friend. Your friend can scan that QR code, get the address, put that address into that field, and then he can send it, right? So that is what it is. This is public addresses of friends who are receiving. These are your friend's address and this is your address, something like that. So he can split one coin into multiple transactions. All these possibilities are made, and then there is a transaction fee that is charged on these, and they get added, right? So now people, when they are picking up transactions to add to a block, people are picking up bigger transaction money. So they are all lying there. So many transactions are lying there. How do I pick the transactions? I can choose some of the transactions which are picked. So some transactions which are having low transaction fee are getting left out. It is like your what do you say, the problem, the smallest job, they get delayed, right? The bigger jobs, they get preference and they move on. There is a starvation in the operating system as you study. So similar things will happen. So these are some of the attacks that are there. So when you want, maybe you are making a small transaction, but you are wanting that this transaction should come forth. So then you should announce a higher transaction fee. So these are all important. Now there's a kind of a estimation that you have to do. How much transaction fee should I pay so that my transaction will be completed immediately? Otherwise, the transaction will not be done and it will be lying there only on the the databases that are there. I will discuss those databases that are there. So this is the amount that is transferred, and then these are the transaction fee, and this is how a kind of one transaction looks like, right? So as I was talking, there are two databases that are there that are maintained. One is called the unspent transaction output. It is said to be UTXO, right? So in a Bitcoin transaction, each input spends the Bitcoins paid to a previous output. So you try to maintain the main parts of the transaction, and there's a transaction 1, transaction 0. So the input spends a previous output. So this is called a UTXO, unspent transaction output. So they are maintained in that, right? So that is there. So when a user wants to spend Bitcoins, you can create a transaction, you can send it to all the peers, you announce that, right? You are having a, let us say, you're not dealing with a public exchange, right? You want to do it private. So you have a Bitcoin core setup, node is set up. From the node, you make a transaction, you announce it to all peers. It goes to everybody. Everybody receives the transaction, and the transaction is stored in what is called a mempool. I will discuss that shortly. So mempool, now many people come and then they pick up them and they become the UTXOs, they put it in that, and then they will try to create a block. All those transactions, they create the hash of those transactions, create the Merkle tree, create the Merkle root, then look at the previous hash, find a nonce value and get the new hash. And once the new hash satisfies the target value, then block is added, right? And the block is confirmed by others, and then and finally the transactions are complete. So all those transactions are removed from the mempool, right? Then the transaction is broadcasted to the entire P2P, and then now you and your friend can be, or you and the vendor can be very happy that the transaction is completed. So these two databases, UTXO, it contains all the spendable outputs that are available to be spent in a transaction. That is one. Mempool is a file that contains transactions which are received by peer nodes but are yet to be included in any block. So they are the unconfirmed transactions. So these are two databases which are maintained. So all along these entire blocks that are added, this data is readily available for you, right? So that all the transactions, all the public addresses, though I don't know to whom the public address belongs, but I know that this public address is making a transaction with this public address. And using data science techniques, using machine learning techniques, or some of these, the entire blockchain can be traversed, and you can build a process in which this one public address you can take and scan through the whole blockchain and see how many transactions he has done, how much money he has, what is his current balance, kind of what are the frequency with which he makes a transactions, how many transactions he has made, how many addresses he has sent money to, who all have sent money to him. This kind of, we don't know who the individuals are, but we know the entire history. But then from there, if you slowly dig in to his geographical address, his this thing, somewhere down the line, right, you can try to create a relationship, right, between, and sometimes some of the public addresses are belonging to the vendors, and those that this person is maybe that it's a Netflix account or something like that, and then that this money is going here, so he is spending money here. So that kind of a thing comes up, and slowly you can try to get as much possible the privacy information as possible. So anyway, of course, you don't actually get to the individual, but then yes, you can get as close as possible, and there can be some related information that is there. So the blockchain is a chain of blocks that are created like this. So this we have discussed. So you can't but you can't change it, because the previous hash are linked. And then if I want to make one transaction change somewhere, there's a big avalanche effect that comes, right? There's a avalanche effect because of the Merkle root concept that is there. So the Merkle root hash is something like this. So you have different transactions here. These transactions, you get these hash values, and then you combine those hash values and so on, and finally you create the root. So this becomes the Merkle root, right? The hash of all the transaction data till here, it becomes the Merkle root. So that's how it is, right? So the proof of work, the consensus algorithms that would have been discussed, the proof of work algorithm is basically you have to calculate the value called nonce, right? So this is the demonstration that I was talking about. You can visit this site andersworthbrown.com and then you can review that. The entire just hands-on kind of this thing, you can look at that, right? Now, the first kind of attack that we can look at is if you want to change the values, there's going to be a big avalanche effect, right? You can change some nodes, but you cannot change all the nodes, right? It's very difficult because every vendor has a copy of the blockchain, right? So it's very difficult to alter or tamper this information. So the avalanche effect is there. So a slight change can cause a predicted output. Because why? Because if you change data in one transaction, it results in the change in the hash of the transaction, right? The Merkle root is created by the hash. So it results in the change in the hash of the block, because Merkle root will influence the hash of the block. This hash of the block will influence the hash of the next block, obviously, because if I want to find the new hash, I depend on the previous hash, and the previous hash is dependent on the Merkle root, and the Merkle root is dependent on the hash of the transaction. So if I make one transaction, the hash of the transaction which influences the Merkle root is changed. If the Merkle root is changed, the hash of the transaction is changed. If the hash of the transaction is changed, the hash of the next transaction is also changed. So this cycle continues and you get what is called this thing. So this is not possible. That's what they say. That is what is immutability. Hence, why people believe or why people want to use blockchain in variety of issues, right? Some of you are talking about healthcare. Some of you are talking about recommender system. Some of you are talking about education, where certificates can be kept secret, or any information which should not be changed. Maybe one of the good example is building records, right? So a lot of problems happen in the registrar's office, right? A lot of times we go to the registrar office, you have to give a big bribe and all, and then to get the document that this land belongs to you is very difficult, because land is something which is, you can't mark it and do it, all of these things. But then you can create a mechanism in a blockchain that if the land records are all digitized onto a blockchain, nobody can change. And when nobody can change it, it becomes very difficult. So you can avoid a lot of corruption issues when you want to go into this. But as yesterday, Dr. Shushmita was also mentioning, any application that you want to develop on blockchain, right? You need to understand that there's an overhead. What is the overhead? You want to store some data and retrieve some data. You may think it's very easy. For a concept to think of that I store the data in Google Drive and retrieve the data, there's no cost that is involved, maybe very less cost that is involved. If the data runs into a few GBs, then Google may start charging you for that, right? Or Azure or any of these cloud service providers which give you storage may charge you for that. But otherwise it's basically free. But here, any transaction you need to do, you want to store some information as a transaction. You don't only have to send money as a transaction. You can send some data also as a transaction, and that data is stored on the blockchain, so it can be verified at any point of time. So in that context, if you look at it, the idea is that the things cannot be changed, but the transaction fee is charged. So whenever you want to store and retrieve data, for storing the data, you have to pay a transaction fee. To retrieving the data, you have to pay a transaction fee. So that is what, in fact, one of the paper we have read on, we have written on trust management in IoT. We have used the blockchain to keep it more secure, to trust the values. But then the point is, of course, on the devices, on the IoT devices, it's very difficult to do that. But then the trust values can be stored and they cannot be changed. They are immutable. So that's something that you can try to look at. So these are some applications. Immutability is one of those aspects. As you see, there are a lot of, one change will change the whole blockchain, right? So if you want to really go ahead and manage these things, so you need to download the entire Bitcoin blockchain. In fact, it can be not only Bitcoin, Ether, or anybody. If you want to do this whole process, so you have to look at the incoming transactions and then create a block, find the nonce. That's what I was talking, right? First, you find out the transactions, create the Merkle root, then find the nonce, find the new this thing, then broadcast the block. And then if the block is accepted, you get your profit, right? So this is the mining process, which I think must have been discussed. So I'm just going forward. So proof of work is basically the algorithm that is used in Bitcoin. So proof of work is, if you are able to do more work, you can create more blocks. That's the point, right? So if you have increasing hardware speed and varying interest in running nodes over time, your proof of work is determined by a moving average, targeting an average number of blocks per hour. So it is usually 6 to 7 blocks per hour to be created. And if more are getting created, then the difficulty value will change. And then there. So usually it looks at in 2 weeks, about 2016 blocks must be created. If it is created more, then it adjusts itself. So that is what is called a target value, right? So of course, now Ethereum was also discussed, Hyperledger was also discussed. In Ethereum, the proof of stake is being used, right? The consensus algorithm is proof of stake, right? So these are questions that are there, which are there. So some concepts, if you look at it, what were the issues? People started using powerful resources. Earlier, CPU, and when Satoshi initially proposed, he said if you have one CPU, you get one vote, you can get one block to be created, right? So one CPU, one block. So then people said, okay, let us combine more CPUs, right? They created clusters, and then they could do that. They could get more blocks. Slowly, people got more greedy, so they used what is called GPUs, graphical processing units, and then the algorithms could be run faster in a parallel algorithmic fashion, because CPUs mostly go on serial because the number of cores that are there are less. So when you want to find nonces for the next value, there are only one core, or maybe there are 4 cores. So at a time, 4 nonces can be found out, and they can be verified. But just imagine a GPU may have more cores, and more nonces can be found out to verify at the same time. Parallelly, you can try to do that, or the entire mechanism can be parallelized. So that is what is a GPU that was doing. Later, people came up with FGPs also, fully programmable gate arrays, and then later what is called ASIC. Yesterday, somebody was asking a question: application-specific integrated circuit. Yes, you create an integrated circuit which does only one application. It is specific to an application. That application is nothing but your mining algorithm. You take the mining algorithm, hard code that mining algorithm into hardware. Okay, that's where VLSI and some of these concepts do come in, FPGA, reconfigurable computing and all. So what you do is you create a hardware chip for the mining algorithm. You take maybe Ethereum, or you take any of those blockchain, and then you create an ASIC for the mining. So what it does, this ASIC is a full computer in itself, but it does only one job, and that is it runs a mining algorithm, and it gives you values, and you use those values and check whether it is correct or not. So that whole process is done using that ASIC. So now, once the ASICs came, people started doing left, right, and center. They started creating blockchains, because the Bitcoin mining hardware, highly specialized computers were created. So obviously, the blockchain community, if you ask, or the distributed ledger community, they started thinking. In fact, people started building coins based on that, and they said, Now, if somebody can have a very powerful resource, he can take over the blockchain. Yesterday, somebody was asking questions also. Can the blockchain be broken? Yes, maybe in some years. Let us say there's a powerful quantum computer realized, right? And if we are able to code this whole expression as a quantum expression there, you can very easily break the blockchain, right? Provided, of course, you need that huge resource to power that algorithm, which will actually help you solve. Keep on adding more blocks, and maybe if you monopolize all the blocks are created by you, then basically you can dictate everything in the blockchain, right? Whatever is done on the blockchain, the one with the biggest power. That's what on day one we're going to talk about that also. That 51% attack is basically based on that. So people started working on this. Now the Asic mining has started. So people looked at a lot of people started building the Asics, and then Asic needs huge computing resource. A lot of electricity is consumed, power is consumed, and hence what happens? A lot of electricity bills are there. So mining pools got together. People got together as pools, put the Asics together, put the computing power together, electricity together, and then they started creating this. So according to the power that they have contributed, they could get their share of the profit, right? So that's what was done. So the thought was people started thinking what can be done, and they came up with new algorithms or new mining mechanisms and new blockchains, in fact, and they have what is called the Azik resistant mining algorithms. So as you bring in new technology, right? And I was talking about quantum computer being realized. By the time a quantum computer is realized, which will implement a mining algorithms and take over the entire, the entire power of these. Okay, so then you tend to realize that these ASIC resistant mining algorithms will slowly come up, and same thing, the quantum resistant mining algorithms will also come up, because there is a mechanism which can resist, right? As you build algorithms which do things faster, you can build mechanisms which delay those things, right? Whatever ASICs could be doing, the ASIC resistant mining algorithms, they resisted whatever an ASIC can do. So ASIC could do something, but then the ASIC resistant mining algorithm needed something which would not, maybe you can create something on reconfigurable computing, looking at the changes that are getting made. So, or each time you try to build a new mining algorithm, a new ASIC or a new quantum computer, and then the algorithm is slightly modified or changed, and then you have to do the whole process again, and then creating hardware is going to be difficult. So the ASIC resistant mining algorithms are developed like a hash coin. So you have the bitcoins, the forking you would have studied. So one of the fork is Hashcash, and then proof of stake is coming up. Of course, it's now already there. So Ethereum, you can look at it in the Casper. Equihash is there, another ASIC resistant mining algorithm, and then we will also discuss Monero. Of course, I will not discuss the resistance part, but then RandomX is there, which is adapted by Monero. Monero is another very private or privacy oriented or confidentiality oriented blockchain. We'll discuss some concepts. Yesterday, I think Dr. Sushmita also mentioned non-interactive zero knowledge proof. Some of them are used by Monero as well. So now you may be wondering where does it stop? How many types of blockchains do I need? Permissionless, permissioned, then public, private. No, sky is the limit. Now, I mean, how much you can do, there is a scope. And what are the challenges? I've already mentioned many challenges, right? Now I'm going to actually delve into a lot of security, because I've done the introduction and I've revised some part of the blockchain for you. Now we will start this aspect of this. So these chains have come up. I think now it's 1 year old. Beacon chain has come. Shard chains have come up. Of course, somebody who discussed Ethereum would have mentioned these to you, right? So a proof of stake is proof of work is the power that you have. Proof of stake is how many bitcoins or how many coins, how much of cryptocurrency you have, or for how long you have kept the cryptocurrency, how interested you are in the blockchain to be successful, right? Then you will be given an advantage, right? So for people who don't have a stake, their what do you say, mining algorithms will run slower. So I don't know how they have done it, but then that's how it is. So because you would want a honest behavior, so that is what is called this. So now we actually come to the security aspect. So what attacks can happen on a blockchain? So one of the important attacks that you can look at is the double spending attack, right? A double spending attack is not possible, but unfortunately, if some seller is very proactive before the transactions are confirmed, if he wants to give away his product. And mostly the products are delivered if it's a hard copy book, or maybe it's a big item, or it's a mobile phone, it may take some time. But if it is maybe a software license, maybe a software download, or maybe you're downloading an ebook and you give the link to download the ebook, done. Once the person has downloaded the ebook and you say, no, the blockchain did not work, please send me back that this thing, you cannot. So here is a simple example, right? There are a few individuals, they are there, and there's Gillen who is making a transaction to Nadir, and there's another person, Brian. Both are the person Gillen is making a transaction. So, but then the point is, he or she can use the same Bitcoin. One Bitcoin she has, maybe the one Bitcoin she is giving to Nader, and one Bitcoin, or maybe 10 Bitcoins. She is giving the same Bitcoins, 10 Bitcoins to Brian, and same 10 Bitcoins to Nader. She has only 10, but she's giving 10 to Nadir also and 10 to Brian also. Both are able to get. So what is there? Gillen is trying to provide this thing, right? So what is the reason for success is buyer sends the same coin to two different vendors. Let us say Brian and the other individual Nadir are two vendors. Both vendors get the same 10 Bitcoins, and but Gillen has only 10 Bitcoins. So if two blocks, each with one of these conflicting transactions, are mined at the same time, these two transactions are going, the two transactions can go into the same block. If it goes to the same block, it can be very easily verified. And said they are coming from the same individual, he has only 10 Bitcoins, and only 10 Bitcoins are to be given, but here there are two transactions. How can I make these two transactions? Not possible. They will be discarded. But fortunately, let us say there are two people who are picking up the mempool. All these transactions are lying. One fellow has taken 10, and the other fellow has taken 10. Each of the transactions have gone into a different block. Both the blocks are mined, right? If both the blocks are mined at the same approximate time, right, and the seller B, he sees that seller A gets the Bitcoin, seller B gets the Bitcoin, but seller B, before he ensures that this transaction got through successfully and completed it, because what you need for a block to be confirmed, it would have been good if it was an interactive session, but anyway, as you're all muted, the answer is we have to wait for the confirmations. At least 6 or 7 confirmations should come before a block can, the block and everything can be added, and I can look like my transaction is done. But I may get that information, but till the 7 or 8 confirmations are received, I don't have to consider that this block is done or this transaction is done. But maybe seller B is active and he says, "Chalo bhai, ho gaya transaction. Let us pay this thing." So he sends out a software or maybe the online book or something, and he sends it out, right? So later he realizes the transaction is rejected. Then there is no way, because if one block gets accepted with that transaction, the other block is supposed to fail because the transaction is not a correct transaction. So these are issues which come. So many times when this double spending attack happens, right, and fortunately it is a trial and error, right? So if both the transactions go into the same block, one of the transaction will get discarded. If both go into two different blocks and they go ahead, and after some time one block gets failed and one block gets passed. So that's a diagram that you can look at it. It's something like this, right? The transaction which gets the maximum number of confirmations from the network will be included in the blockchain. So what has happened? Seller B gets a transaction, but this transaction is not going ahead because there is one wrong transaction here. Because this transaction has been successful, the 10 Bitcoins that Gillen had are spent. The other 10 Bitcoins which are going to Nadir are not available. Hence, the transaction is not validated. When the transaction is not validated, this block is abandoned. When this block is abandoned, this is rejected, because here, if you get 6 confirmations, as more and more blocks get added, it receives more and more confirmations. And as it receives more and more confirmations, more and more blocks get added, the blockchain grows. As the blockchain grows, that becomes the official blockchain. And this block, which also added as another false transaction, that block gets dropped. And once a block gets dropped, right, all these transactions are reversed. Sometimes these things happen and they move forward, and here also some transactions are there and they move forward, but these transactions are maybe few transactions are not correct, like the double spending transaction has happened here. The remaining transactions are also sent back to the pool. Similarly, Gillen's transaction also comes back, and Gillen's transaction is verified again. And when you see the transaction, Gillen doesn't have, because by that time this block is added, because this block is added for who is that person? Brian. So Nadir's transaction is nullified here. So it comes back, and when you check, Gillen doesn't have more 10 bitcoins to give. She has no bitcoins, but she's wanting to do 10 bitcoins to Nadir, which is not possible, right? But Brian has successfully got it, and then this proceeds, and this is accepted. So these are the successful. What is there? The seller B must be careful to avoid double spending, right? Buyer succeeds in double spending by confirmed transaction to seller A and rejected transaction to seller B, but receives the services from transaction seller B. Seller B's problem or vendor B's problem, right? So he has to be careful. But then the next thing we talked about is the 51% attack on this thing. 51% attack is when a single miner or a group of miners attains majority of the network's hash rate. So in that case, what happens? They prevent transactions and blocks from being verified. You cannot, you can, a group of friends are there. So all of them are there. They know who is adding the block. So obviously they will all verify it. So the majority of people, if they are belonging to, they are your friends, you can actually form a syndicate. But fortunately till now, in the blockchain, this is not possible. But whenever this is possible, you get what is called a hard fork, right? So blockchain splits because people claim this is also correct, people claim this is also correct. Both the chains are said to be correct. After that, both chains proceed for a long distance. Then they have to sit down and reconcile. Somebody has done something wrong, but then both the chains have grown to a long distance. Now you can't dump both the chains. So the new chain or a chain which is, they have to agree and compromise that, okay, let us continue further, no problem. And they have both these things. So some part of the chain is common, and from there is a split, and then there are multiple chains that are there. So this is what happens, right? This is the 51% attack. So what happens when the majority share takes over? Now, this can happen when huge resources are available with one particular group of miners. So as they get more and more rich, and they invest more and more money into resources and computing and power supply and all that, so they get majority of the network's hash rate. Just imagine somebody was working with the Bitcoin mechanism, right? A huge power was there at his disposal. Suddenly he says, now what ho gaya? Let me do somewhere else. So he goes to Dogecoin or something. It's a very small network, right? And then he can use all his resources and take over the network. Kind of easy. But then still, even then, it is really not possible, because there are so many people involved in the whole world, and you can't stop any of them because they're very decentralized. It is distributed, right? So there is no centralized this thing. There is no way to estimate how many people will get involved. So any number can get involved. Anybody can do anything. So that's where the whole aspect goes on. So you can't prevent the transactions. You can't have the blocks from being verified. You can, maybe reverse the transactions to allow double spending. So you can, some transactions are coming back saying that these are not valid, but then again, you can again add it to another block and send it. And finally, they can get adjusted because other miners will approve the transaction. So maybe the money is not received, but the transactions are approved. Prevent other miners from finding any block and then you can also fork the blockchain. So once you have that 51% of the power, more than 51% of the power, more than half of the power, that's the basic idea. And it's very difficult in that sense, but then it's not impossible, right? It's not impossible to create a huge resource. As more and more pools join together to form a bigger pool, it's not difficult to defeat the remaining people, right? It can happen when there is a centralization by mining pools which acquire more than 50% of the hash power. It is easy to implement in altcoins. Smaller coins, it's easy to take over. In order to control 51% of an altcoin's hash rate, only a small proportion of the miners from larger coins needs to switch to a smaller coin. As I discussed, from Bitcoin, if you want to come to Dogecoin or some Lakshmi coin or some of these coins, very easy to do that, right? Very difficult for blockchains like Bitcoin and Ethereum because there's so many people interested. The cost is also more, and hence it is difficult, but it gets much cheaper quickly for newer blockchains. So you will need about $1.5 million to execute a 51% attack on Ethereum Classic, which is having a market cap of $2 million. So almost 1 million and 2 billion, right? So that's almost maybe 100 times. So that's the kind of resource that you need. But as the whole world over, people are competing and they are putting their resource into it. So as of now, this is getting resisted. But there will be a time where if I get those resources, I can very easily take over that. Ethereum hard fork happened and it became Ethereum Classic 3 times in August 2020, right? So attack can be identified by unusual high rate of orphan blocks. A lot of blocks are created and they're left dumped, right? So that's what it is there. And then sometimes it has. So a blockchain dash uses a secondary validation layer called chain locks. So to prevent these, what you call 51% attack, they have a mechanism called chain locks, right? So what happens? It prevents block reorganization by making it expensive for the attacker. So there are these variations also are what differentiates and separates different blockchains. So that's where for specific reasons, you can create different blockchains, right? As Monero, we discuss in some time, we will see that it requires, it handles confidentiality and privacy. So that's what is there. So that's the 51% time. Dr. Sushmita made a passing remark to what is called is selfish mining attack, right? What is selfish mining? Selfish mining is something like this. Block is created, block 2 is created, and after that block n is created. So there are different miners who are looking at block n plus 1. And there is one miner, miner A, let us say, he has got block n plus 1. What he should do? He should announce to everybody that I've created block n plus 1. But because he's selfish, he's a selfish miner, what he does, he doesn't announce. So there are other individuals who are still struggling, and finally they get block n plus 1. Meanwhile, what this fellow is doing, he's not announced block n plus 1, but he started searching for block n plus 2. By the time some transactions have come, he picked up some set of transactions, identified that these transactions I'm taking for the new block, and then he's trying to add it to a new block and then creating a new block, finding the new Merkle tree, finding the new nonce, finding the less than the target value, adding a block. 2 blocks are added. He's not still announcing. What he's doing? He's announcing the third block. He's looking for the third block also. Suddenly, multiple blocks are added. Here, by this time, n plus 1 is added, n plus 2 is getting added. This fellow is added, n plus 3 also. And after that, he announces all the 3 blocks in the same time. You would have seen some blocks, right, which are created in 1 minute duration, right? What are they? They are actually these blocks. This block was created, then this block was created. This block was not announced. But later, 3 blocks were suddenly announced. In a duration of 3 minutes, 3 blocks were added one by one in the same blockchain. So what has happened? There are two sets of sequence. There are 3 blocks on one side and there's 1 block on one side. The second block is getting added. By the second block is getting added, but the third block has already been added here. So others will come and give more confirmations here. And when they give more confirmation here, this selfish chain becomes the actual chain. And this chain the honest chain gets dumped. So this is the kind of process that people are having. So why should I announce immediately? Let me build a blockchain of 4 or 5 blocks, and at the same time, I get all the 4 or 5 blocks money in one go. That is what is called a selfish mining. Now, just imagine how much of programming, how much of algorithmic thought process, how much of resource management has to be in place to ensure that you should take a risk like that. So you earn 4 blocks instead of 1 block in no time by just making a small change in the usual mechanism. Honest mining, and this is dishonest mining, right? So that's what they deliberately keep their blocks private. As they discover, they continue to mine their own private blocks, and they create a chain longer than the usual public blockchain. They select, suddenly they realize the private blocks, and then they get all the blocks are added. So all the blocks they get, and they get a higher reward, right? And these honest miners are doing those, and they lose that money. So there was a distributed denial of service attack. Wherever there is a resource, people can keep attacking. So DDoS, you have seen in multiple ways where a system becomes unavailable, right? So availability attack, DDoS is an attack on availability. So here we see that you can have DDoS attack on the distributed network also. But multiple distributed DDoS attacks were launched on competing miners. So you are doing mining process, but you don't want others to win, right? Maybe the 3 idiots formula, right? You work hard, but you disturb others. One is all of them are working hard. Whoever works hard will get the best. But one is working hard but disturbing the others. So what happens when the others get disturbed? You tend to do it faster. So others are put to DDoS attack, and you are actually doing mining, and you are successful because they are running programs, and their programs are their systems are shut down, reset, and network is down. All of these things happen, and there's a lot of problem. Hence, you launch them on competing miners. You take them off the network, and then you get a more bigger share of the miners hash rate. Similarly, honest miners, you put some transactions which are actually waste transactions, right? So fake transactions you put, and then you are doing what the fake transactions are, so you don't do the transactions because there is no transaction money there. You take the actual transactions which are not fake, and then because you know them, you identify, and then you reduce the chance, you reduce their chance of mining. So that is a DDoS attack. So now this is slightly beyond blockchain. What happens? There is a DNS network, right? So DNS server is there. So what you do is you isolate a user from the real network and lead them to a fake network, which is actually not the blockchain network. You are a Bitcoin node, what is called Bitcoin core. You have set up a node. The Bitcoin node setting up software is called Bitcoin core. So that software, when you set up, you become a node. So this node gets connected to the blockchain by going to a DNS. But then if you attack the DNS, the domain name server, right? The domain name system server, DNS server. If it is compromised, I say I want to go to the blockchain, and the DNS replies, go to this blockchain. This is the blockchain. But I want to actually go to the actual blockchain. I am sent to a fake blockchain, and I start making the transactions there, right? So that is what actually happens. So this is the actual blockchain network. I should go here to the DNS server. DNS server should direct me here. But what is the DNS server doing? Oh, sorry, the user wants to go to the blockchain. But this attacks has DNS cache has been poisoned. So when I go here and ask for an address, this cache poisoning will return a new address. This is a different address. This is a different address. So the address that is returned is a different address. And when you use that address, you go to a different network. It looks like a blockchain, like a phishing attack. You want to go to bank, this thing, but it is actually taking you to some fake website, right? So these are some of the things that happen at the network level, right? So the fake entry point nodes return to the user. User could do routed to the alternate network rather than the current blockchain. So at the DNS network level, you can do cache poisoning, and then you can do that. Then there are eclipse attacks. There are a group of malicious nodes isolate its neighboring node and compromising their incoming and outgoing traffic. and they change the blockchain view of the honest node, right? So there are a lot of nodes which are there, and then they make up the distributed network. And when you want to actually interact, so a group of malicious nodes, some of the nodes which set up the Bitcoin core, so if they want to act malicious, they can create a network. It's something like your wireless sensor network nodes. Similarly, you can have here a network nodes which are having, so they can compromise their incoming and outgoing traffic, and they change the blockchain view. So feed them with fake information regarding the blockchain transactions, and then they are there. So all these white ones are the safe nodes, but all the pink ones are there. So what happens? The white nodes are honest nodes which are attacked by the red malicious nodes. So they are, and slowly as the white nodes are attacked by the malicious nodes, they also become the malicious nodes, right? So the malicious nodes then send fake transactions and block to these nodes. The white honest nodes attacked by red malicious nodes, they are also becoming the malicious nodes. Coming to the privacy attack, as we look at, blockchain is considered anonymous because the user is identified by its address only and can generate as many alias addresses as possible. Right? You can create multiple alias addresses. In fact, in virtual machines also, once you create a virtual machine, you can create multiple alias addresses, right? Because the hypervisor knows the address and you can try to create. In a similar sense, in blockchain, you can create multiple public addresses, right, out of that. So you can actually hide yourself. You can have multiple public addresses, and then you can generate as many addresses as possible. They will point to the same wallet, but you can have multiple addresses, right? So a blockchain is replicated at each node. As we know, the observer can use the transaction history in the blockchain to find the topology of the network. So this is what I was talking about, right? When Bitcoin core nodes are set up, and they're all different nodes are set up from different points. So blockchain keeps track of how many physical nodes are there. They can come from an exchange also, but the exchange aspect is different. So the exchange is connecting. So the exchange has more wallets. They are all maintained. So that's where the role of the exchange comes. When you create an account with the exchange, your private key is not with you. Your private key is with the exchange. So that's a solid disadvantage. And that's where the eKYC and all the transactions that you do are open to the wallet and open to the government for scrutiny. So you can use the exchange, you can trust on them, because again, there is no centralized agency. Suddenly one day the blockchain is closed, there's nobody who can help you. So that's the question. So here, as you look at it, the topology of the network can be created, because whenever a node is created, the node has an address, and you can easily track that address and find out. So that's something that you can try to look at. You can get the topology of the network, right? And then you can get the patterns of the transactions. As I told you, all the transactions are there, and then you can try to get to the network node where they are connecting from. You can get to their IP addresses to a large extent, and then you can look at all the transactions that they're doing. You can do all the user interactions that it is doing. So all these things are taken place, and then you can try to do that, right? So that's something that you can do, right? So I'll just take a small break here, and then we'll continue in about 5 minutes, right? I just stop here. Then maybe before I start, we will have a lot of questions to be addressed. So I will answer the questions and then start forward. Just we'll take a 5-minute break.
Dr. Pilli, thank you.
Yes, ma'am. I've just taken okay, are we going for a break?
No, I just wanted to know if, because it is already 11, are you going to answer some questions which are there on the chat box?
Yeah. I'm just taking some water break. I'll answer some questions, then we'll take a break, right?
Okay, fine.
Yeah. Just give me 5 minutes.
Thank you.